Welcome to another deep dive, and today we're taking a close look at communication systems. We've got a really cool collection of notes and diagrams with us.
Yeah, it's all about the fundamentals of communication engineering.
I think this will be a great kind of crash course on how all this stuff works. I mean, everything from a simple phone call to, a satellite broadcast.
It's amazing, right? You just pick up the phone or flip on the TV. You don't even think about all the signals flying around behind the scenes.
Exactly, and that's what we're going to unpack today. Our mission here is to really break down those core elements, and that's for any communication system out there.
It could be simple or it could be super complex. Doesn't matter. But every system starts with a basic definition. Our source material defines communication as the process of establishing connection or link between 2 points for information exchange.
Makes sense to me, but it's that connection part where things get interesting, right?
Absolutely, and that's where we need all this electronic equipment. It all works together to create what we call a communication system.
Okay, so like we're talking hardware, software, the whole shebang.
Exactly, and these systems, they're everywhere you look. Line telephony, radio telegraphy, radio broadcasting,
Mm-hmm.
you name it. Even things like point-to-point communication or radio telemetry, navigation aids, aircraft landing system.
Wait, so those are communication systems too?
Oh yeah, think about it. They're still exchanging information.
I guess you're right. It's like vital signs, but for ships or planes.
Or even spacecraft across vast distances.
I never really thought of it that way, but I guess it makes sense.
And here's the really cool part. Despite all the variety, they all follow a similar blueprint.
You're talking about that block diagram, right?
You get it. It's like a common language for understanding how they all work.
Okay, I'm ready to decode this language.
Perfect. So where do we begin? Well, at the beginning, of course.
Fair enough. So what's the first block in our diagram?
The information source. It's where the message originates. Think of a radio DJ speaking into a microphone.
So in that case, the DJ's voice is the information source.
Exactly. But it could just as easily be a text you're typing or a video you're streaming. Really any information that needs to be shared.
Okay, that makes sense. It all starts with that message.
The source material puts it this way.
Right.
Words, group of words, code, symbols, sound signal, etc.
So really any information we want to communicate, huh?
Precisely. But there's a catch. We need to translate that raw information into something a communication system can use.
Right, because our thoughts and words don't just magically transmit themselves.
Uh-huh. Exactly. That's where the input transducer comes into play.
Ah, yes, the translator, if you will.
Precisely. It converts that message into an electrical signal.
So in our radio example, that would be the microphone turning sound into electrical pulses.
You got it. It's taking something we understand and converting it into something the system understands.
So it's not just converting, it's almost like encoding, right?
That's a great way to think about it.
Okay, so if the microphone is the input transducer for a voice, then what about when I type a message on my phone?
Good question. In that case, it's the keyboard on your phone. Each keystroke is turned into a specific electrical signal.
So it's representing each letter or symbol I type as a signal the phone can understand.
Exactly. And for a video stream, it would be the camera, converting light into electrical signals for each pixel.
Wow, this is making me look at my phone in a whole new way. Okay, so we've got our message, we've converted it into an electrical signal. What's next?
Now we need to send that signal on its way. That's where the transmitter comes in.
And that's the powerhouse of the system, right?
It gets the signal ready for its journey through the channel.
Ah, yes, we talked about amplification before. That's where the signal gets boosted so it can travel further.
Right, just like turning up the volume so it can be heard across a noisy room.
Hmm.
But there's another crucial step, modulation.
Right, that's like giving the signal a special pass to travel on a specific channel.
Exactly. It's all about preventing interference. Imagine if every radio station just blasted their signals out on the same frequency.
It would be a cacophony. We just hear a jumbled mess.
Exactly. Modulation keeps everything organized. It's like assigning each station its own lane on the highway.
So that's how my Wi-Fi doesn't get disrupted by my neighbors.
You got it. Modulation keeps those signals separate and clear.
Okay, so the transmitter amplifies and modulates the signal. But how does it actually travel then?
That's where the channel comes in. It's the pathway our signal takes to reach the receiver.
So that could be radio waves traveling through the air.
Exactly. But it could also be fiber optic cables or even copper wires.
So it's essentially the medium that carries the signal.
You got it. But like any road, it's not always smooth sailing.
You're talking about noise, right? That interference that can mess things up.
Precisely. Noise is a fact of life in any communication system.
I guess it makes sense. There are always going to be disruptions.
They can come from natural sources like atmospheric conditions, or man-made sources like electrical interference.
So even with a strong modulated signal, noise can still cause problems.
Absolutely. Think about static on a radio or a dropped call. That's noise wreaking havoc on your signal.
Okay, so how do we combat this noise?
Well, that's where the receiver comes in. It's tasked with capturing that transmitted signal from the channel, noise and all, and then converting it back into a usable form.
So it has to sift through all that interference and extract the original message.
Exactly. It's like a detective trying to solve a case.
Hmm.
But the receiver has a secret weapon: demodulation.
So if modulation is like putting a message in a coded envelope, then demodulation is like opening that envelope and reading the message.
A perfect analogy.
Yeah.
But what happens if the message gets garbled because of noise?
Yeah, like if the envelope gets ripped or water damaged or something.
Well, that's where the receiver's filtering abilities come into play.
It's like having those noise-canceling headphones, but for the signal itself.
Exactly. The receiver tries to filter out as much noise as possible.
That's pretty impressive. It's like having a built-in noise filter for our communication.
Yeah.
Okay, so the receiver captures the signal, demodulates it, and filters out noise. Where does the message go from there?
It's almost at its final destination. That's where the message is delivered to its intended recipient.
So in our radio example, the destination would be the listener's radio speaker.
Exactly. It converts that electrical signal back into sound waves.
And for a text message, it would be my phone screen displaying the text.
You got it. The destination is the endpoint of the communication journey.
Wow, this block diagram is really starting to make sense now. We start with the information source, convert it into an electrical signal, transmit it through a channel, receive and decode it, and finally deliver it to the destination. It's like a carefully choreographed dance.
It really is. And what's fascinating is that these principles apply to every communication system out there. From a simple phone call to a global broadcast, it's all about getting a message from point A to point B.
This has been an incredible journey so far. We've learned about the source, the input transducer, the transmitter, the channel, the receiver, and now the destination.
And we're just getting started.
I can't wait to dive deeper into each of these elements.
Sounds good. Let's move on to the next stage of our deep dive then. We'll really unpack each block in more detail.
Okay, so we've got our blueprint, that block diagram all laid out. Now let's zoom in on each element and really get into the nitty-gritty.
Yeah, let's explore the terrain.
Exactly. So we started with the information source, the birthplace of the message itself.
It can be anything, right?
Yeah, from a fleeting thought to, a complex data set.
Absolutely. Our source material calls it the message or information in the form of words, group of words, code, symbols, sound signal, etc.
Really, anything we want to share.
Precisely. And to share it effectively, we need to translate it, right?
Right, because our thoughts and ideas, they don't just magically transmit themselves, do they?
Nope. That's where our good friend, the input transducer, steps in.
Ah, yes, the translator.
You got it. It converts that message into an electrical signal.
It's like a bridge between us and the electronics.
A bridge between the world of human experience and the world of electronics. I like that.
So it's not just converting, though, is it? It's also
No.
about encoding.
That's a great point. Putting those thoughts and ideas into a format machines can understand.
Like when we were talking about that microphone in radio broadcasting.
Right. It takes all the nuances of a human voice
Mm.
and turns them into electrical signals.
Capturing the essence of the voice, but in a totally different form. So what about when I'm typing a message on my phone? What's the input transducer there?
In that case, it's the keyboard. Each keystroke, each tap generates a signal.
So it's representing each letter or symbol with a unique signal.
Exactly. And for a video stream, it would be the camera.
Converting light into signals? Amazing. Okay, so the input transducer really is a bridge. Once we have that electrical signal, what's next?
Well, now it's time to send that signal on its way. That's where the transmitter comes in.
Ah, yes, the powerhouse of the system gets the signal all ready for its big trip.
Exactly. And remember, we talked about amplification.
Yeah, boosting that signal strength.
Right. But we can't forget about modulation.
Oh yeah, modulation. That's like giving the signal a VIP pass, right? So it can travel on a specific channel.
Exactly. It's crucial for preventing interference. Imagine a world without modulation. Every radio station, every Wi-Fi network, all jumbled together.
Oh man, yeah, that would be a nightmare. So modulation keeps everything organized.
Keeps everything running smoothly.
It's like we're assigning each signal its own lane on a highway.
Love that analogy.
So instead of just sending the raw signal, the transmitter modifies it to fit within a specific frequency range.
Exactly. And that allows it to coexist with other signals.
It's brilliant.
And there are actually different types of modulation.
Oh, really? So it's not a one-size-fits-all kind of thing?
Nope. Different types for different purposes. Your Wi-Fi uses a different modulation scheme than your phone does.
Wow. So it's like choosing the right vehicle for the journey.
Exactly.
Okay, so we've got our amplified and modulated signal. Now it needs to travel, right? That's where the channel comes in.
You got it. The pathway our signal takes to reach the receiver.
And we know that can be all sorts of things, from airwaves to fiber optic cables.
Each with its own unique characteristics.
Right? Like fiber optic cables, they're known for being super fast and reliable.
Exactly. High bandwidth, low noise, perfect for tons of data.
But even with the best channel, we can't ignore noise.
Noise. The bane of any communication system.
Whether it's a thunderstorm messing with a radio signal or someone accidentally cutting a cable, noise always seems to find a way.
It's like those unexpected detours and roadblocks you mentioned earlier.
Exactly. So the receiver has to deal with all that.
Oh yeah, it's got a tough job.
It has to capture that signal, noise, and all.
And then try to extract the original message from that mess.
Talk about a challenge.
It is. But luckily, the receiver has some tricks up its sleeve.
So it's not just receiving, but also filtering and decoding.
You got it. It uses demodulation to undo what the transmitter did.
Ah, so it's like reversing the modulation process.
Exactly. And then it uses these really sophisticated filtering techniques.
To minimize all that noise.
Yep. Like a set of noise-canceling headphones for your signal.
That's a great analogy. Okay, so let's say the receiver's done its job. Demodulated the signal, filtered out the noise. What happens then? Where does the message go?
It's finally reached its destination.
The intended recipient, the end of the line.
Exactly. And here it's converted back into something we can understand.
So if the input transducer was all about encoding, the destination is all about decoding.
You got it. Think about listening to music on your headphones. The receiver in your phone demodulates and filters the signal. And then the speakers act as the destination.
Right, they convert those electrical signals back into sound waves, and when I get a text message, the destination is my phone screen, displaying the text in a way I can read.
Exactly. The destination completes the loop.
Takes us back to the human world.
Back to the world of human perception.
This is amazing. We've gone from the birth of the message all the way through its transformation and journey, and finally, to its delivery.
It's a cycle that's happening all around us, constantly.
This has been an incredible deep dive so far. We've covered so much ground.
We have the information source, input transducer, transmitter, channel receiver, and destination.
It's really making me appreciate how much goes into communication.
It really is a marvel of engineering, but there's still more to explore.
Okay, I'm ready for more. What else is there?
Well, we've talked about the present, but what about the future?
Okay, so we've journeyed through all the inner workings of communication systems, how they work today.
Right, the nuts and bolts.
But technology never stands still, does it?
Never. It's always evolving.
So what does the future hold for how we connect and share information?
That's where things get really exciting. We're on the verge of some major breakthroughs.
I'm all ears. What kind of changes are we talking about?
Well, remember when we were discussing the channel, the pathway for our signal?
Yeah, we talked about how it could be anything from airwaves to fiber optic cables.
Right, we've gone from copper wires to those super fast cables. But the next leap could be even bigger.
Okay, you're not going to tell me it's telepathy, are you? Because I've seen enough sci-fi movies to know how that goes.
Uh-huh. No, not quite telepathy. But we are moving towards communication that feels almost instantaneous and boundless.
Okay, now you've got my attention. Boundless communication.
Imagine a world where your internet connection isn't limited by cables at all. What if it was beamed down from a network of satellites?
You're talking about satellite internet.
Exactly.
I've heard of that, but it's always seemed kind of slow and spotty.
That's all changing, though. There are these new constellations of low Earth orbit satellites. They're being launched right now, and they promise super fast internet.
Wow, even to remote areas.
Even to the most remote corners of the world.
That could be huge for rural communities, developing countries, disaster relief.
Absolutely. It
Yeah.
really democratizes access to information.
Speaking of access, let's think about the destination for a second. Right now, we mainly interact with devices through screens and speakers.
Right. But what if communication became more immersive? more integrated into our lives.
Okay, immersive communication. What does that even look like?
Think about virtual reality meetings, where you feel like you're really in the same room with people, even if they're across the world.
Wow, yeah, like a hologram or something.
Exactly. Or augmented reality glasses. They could overlay information onto your field of view.
Hold on, are we talking about a world where distance doesn't matter anymore?
That's the potential. And it's not just about convenience either. Think about the possibilities for education, healthcare, entertainment.
Yeah, I mean, even just connecting with loved ones would be different.
It could revolutionize how we interact with each other and the world around us.
It sounds incredible, but also a little scary, to be honest.
That's understandable. As communication technology gets more powerful, we need to be mindful of the ethical implications.
Right, it's a powerful tool, and like any tool, it matters how we use it.
Exactly. Privacy, security, digital well-being, these all become even more crucial.
We need to make sure these advancements are beneficial for everyone.
Absolutely. It's not just about the technology itself. It's about our values, our intentions. We have a responsibility to shape these advancements in a positive way.
That's a really important point, I think. So, as we're all excited about these incredible breakthroughs, let's not forget about the human element.
Well said. It's about using these tools to build connections, to share knowledge and experiences, and to create a future where communication really empowers us.
I love that. So, to wrap things up, we've taken a deep dive into the world of communication systems. We've explored how they work, from the basic principles to the cutting edge, and we've even peeked into the future to see what might be coming next.
It's been an incredible journey.
It really has. Thank you so much for sharing your expertise with us.
My pleasure.
And to everyone listening, thank you for joining us on this deep dive. We hope you learned something new and that you'll keep exploring the amazing world of communication systems. Until next time.